Good afternoon everyone. Today we will study about the experiment number 4, that is focal length of a convex lens by plotting a graph between u and v, where u is the object distance and v is the image distance, or between 1 by u and 1 by v. So the aim of the experiment is to find the focal length of a convex lens by plotting graphs between u and v, or 1 by u and 1 by. So these are the apparatus required to do the experiment. This is a screen. This is a lens holder. These are two pins which work as one as the object pin, one as the image pin. This next is the thread and a convex lens and a convex lens and a meter scale. This is the meter scale. Next is the formula used in this experiment. It is focal length of the convex lens is given by f is equal to u into v divided by u plus v. That is in centimeter. Next, let us come to the nature of the graph. So the nature of the graph, we have two natures of graphs in this experiment. This is the nature of the graph. The first graph is u versus v for a convex lens. So this graph comes in second quadrant. As we get u, that is the object distance, as negative and the image distance as positive. So why we get this? For that, let us see the ray diagram once again. So in this ray diagram, as you can see, this is the object distance u and this is the image distance. The image distance is measured with respect to the ray, direction of the ray. That is, the rays are traveling in this direction and v is taken up from optic center to the image in the same direction. So according to the sign convention, whenever the measurements are done with respect to or in the direction of the ray, then they are taken to be as positive. So the image distance becomes positive. Same way, here you can see we are measuring the object distance from the optic center to the object in the negative direction with respect to the in the rays which are coming. So we are measuring the object distance in the opposite direction. So according to the sign convention, this is taken to be as negative. So the object distance is measured as negative and the image distance is taken as positive. So the graph u and v we get in the second quadrant. So when we plot this graph u, so when we draw the graph and when we draw an intercept at a 45-degree angle, we get two measurements, on one on y-axis and one on x-axis. Using this distances, distance OA on y-axis and distance OB on x-axis, we will find the mean focal length of the convex lens, that is given by OA plus OB divided by 4. That is taken in centimeter as well as in meters. Next is the second graph, that is 1 by u versus 1 by v graph for a convex lens. Here this graph also comes in the second quadrant, as the reciprocal of the object distance will again be negative. So after plotting the points, the line which we extend, they meet at 2 points on a x-axis and y-axis. Taking that intercepts, again we will find the mean focal length. So the focal length on the intercept on the y-axis is intercept OA dash on y-axis and intercept OB dash on x-axis, which will give the mean focal length of the convex lens, that is 2 divided by OA dash plus OB dash, that is in centimeters and again in meters. Next is the ray diagram, which shows us this is the object and this is the image. So when the object is kept behind 2f, the image is formed between f and 2f. As in theory, you know where the position of the image is formed when the object is kept at a certain distance. This is the tabulation which shows the position of the object and the position of the image. So when the object is kept at 2f, the image is also formed at 2f and the nature of the image is real and inverted. When the object is kept between f and 2f, the image is formed beyond 2f. Again, the nature of the image is real and inverted. When the object is kept beyond 2f, the image is formed between f and 2f. Again, the nature of the image is real and inverted. When the object is kept at f, the position of the image is at infinity and the nature of the image is again real and inverted.